Hello friends, welcome back to Sea Level Physics. My name is Srinivas, known to be BS Rao. Today I came up with wonderful concept. It is none other than relative velocity. Right? It is very important, crucial topic. Why? Because it decreases the toughness into easiness while solving sums. So it has found so many applications while solving sums in various chapters. Okay. Now let us see relative velocity. What is meant by relative velocity? By the name itself, velocity of any body with respect to another body is known as relative velocity. Right? Velocity of one body with respect to means relative to another body. Okay. Now, if velocity of any body with respect to ground is said to be absolute velocity. That's what written on the board here. See, relative velocity. Relative velocity in the sense velocity of one body with respect to another body, otherwise relative to another body. Right? Now, absolute velocity. Velocity of any body with respect to ground. Suppose if you measure velocity of any body with respect to ground, then it becomes absolute velocity. Okay. Suppose velocity of A with respect to B. A is one body and B is another body. As an example, here VAB bar means what is VAB bar? Velocity of A, body A, with respect to another body B. Right? See alphabet, first letter A. So it is what? Velocity of first body, that is A, of A. See the second alphabet, that is B, means with respect to which velocity of previous body is measured. So VAB means velocity of A with respect to B. See here, velocity of A with respect to B. Otherwise, velocity of A as measured by B. So it is nothing but relative velocity of A with respect to B. Right? That can be measured mathematically VA bar minus VB bar. So VAB bar equal to VA bar minus VB bar. That is VAG bar minus VBG bar. What is VA bar here? VA means velocity of A. Here nothing is there by the side of A means with respect to ground. Okay, it is granted like that. See, VA means velocity of A. Here nothing is there means with respect to ground. So VA is nothing but VAG. G means ground. See, now itself I told you that velocity of any body with respect to ground is absolute velocity of that body. So VA means velocity of A with respect to ground. Otherwise, VAG is velocity of A with respect to ground. So, therefore, it is what? Absolute velocity. Minus VB. VB means velocity of another body B. Velocity of body B here. So, velocity of body B with respect to whom nothing is there means take it as granted with respect to ground. So, VB is nothing but VBG. Means velocity of B with respect to ground. So, this one also absolute velocity of B. Right? So, therefore, what is relative velocity of A with respect to B means absolute velocity of A minus absolute velocity of B. Right? Otherwise, velocity of A with respect to B equal to velocity of A with respect to ground minus velocity of B with respect to ground. Right? That's what written here. See, relative velocity of any body. Here it is of A. Relative velocity of A. So, relative velocity of any body can be written as velocity of that body with respect to ground. See, velocity of that body with respect to ground minus velocity of observer with respect to ground. Right? So, relative velocity of A with respect to B means velocity of A minus velocity of B. That is, velocity of A with respect to ground means velocity of B with respect to ground. Okay, here VA means VAG, VB means VBG. Okay, suppose VBA bar means what? What is VBA? VB means velocity of B with respect to whom? With respect to A. So, velocity of B with respect to A. Otherwise, velocity of B as measured by A. Otherwise, relative velocity of B with respect to or relative to A. So, as per previous formula here, it can be written as VB bar minus VA bar. That is VBG bar minus VAG bar. So, velocity of B with respect to A equal to absolute velocity of B minus absolute velocity of A. That is velocity of B with respect to ground minus velocity of A with respect to ground. So, what is meant by relative velocity? Velocity of any body with respect to ground is absolute velocity. Velocity of any body, velocity of one body with respect to another body is known as relative velocity. Now let us see some examples. When both moving in same direction. Suppose here two bodies are there, A and B, both are moving in same direction as shown. See, body A moves with 20 meters per second rightwards, body B also moves with 50 meters per second rightwards. So both are moving in same direction. So in that case, velocity of B as measured by A, that is VBA bar, velocity of B with respect to A, that is, what is the formula? VB bar minus VA, VB bar minus VA bar, right? VB bar minus VA bar, okay, that is, as it is one dimensional motion, no, there is no significance for arrow mark bar, so I'm excluding arrows here. VBA can be written as VB minus VA, right? What is VB? That equal to, VB means what? 50 meters per second minus VA means what? See, VA also in the same direction of VA, velocity of A also in the same direction of velocity of B. So it is positive, this is also positive. So therefore 50 minus of plus 20. That is what? 30 meters per second. Positive sign, with positive sign means, see, A measures as if B moves with 30 meters per second rightwards. 30 meters per second rightwards. Am I right? So this is what? Relative velocity of B with respect to A. Right? Now, in second case, when both moving in opposite direction. See, in the same example, body A, right, 20 meters per second, body B moves with 50 meters per second, but both are in opposite direction. See, A is rightwards but B is leftwards. Now what is velocity of B as measured by A here? VB bar, that is VBA bar, can be written as VB bar minus VA bar, right? VB bar minus VA bar, that is VBA also can be written as VB minus VA. Now what is VB? 50 meters per second. Suppose if it is positive direction, this is negative direction. See, VB 50 meters leftwards, 50 meters per second leftwards. If it is positive, so 50 meters per second minus. What about VA? VA is negative. Why? Because with respect to B, the direction of motion of A is opposite with respect to B. So therefore, if 50 meters per second is positive, 20 meters per second definitely negative. That is minus of minus 20. Minus of minus 20. That is what? 50 plus 20. That is 70 meters per second. 70 meters per second. So here, A measures as if B moves with a speed of 70 meters per. Now example 3. Here, person A is standing on the ground. Person B also standing on the moving trolley. What are the particulars of a trolley here? The velocity is 10 meters per second, acceleration 5 meters per second square, and displacement covered 20 meters. Now with respect to ground, person B also moving along with the trolley, right? So therefore all these factors or all these values also belongs to person B also with respect to ground, right? So if A is the observer and is going to measure all these particulars for B, now velocity of B with respect to A, that is VB minus VA, right? VB minus VA. What is VB? Velocity of B means 10 meters per second with respect to ground. See, is it absolute velocity or not, right? Why? Because VB means VBG. VB means VBG. Minus VA means VH. So VBA means velocity of B with respect to A is equal to velocity of B with respect to ground minus velocity of A with respect to ground. Means these two absolute velocities. right? That is VBA equal to what is VBG? Velocity of B with respect to ground is 10 meters per second. Of course, with respect to trolley, he is at rest. But at the same time, as B moves along with the trolley with respect to ground, all these particulars even belongs to B also. Therefore, what is VBG? 10 meters per second. 10 meters per second. Minus what is VAG? VAG means with respect to ground A is at rest. So 0. 0. That is 10 meters per second. Alright. Now what about acceleration of B as measured by A? That is A, B, A. Acceleration of B as measured by A. That is with respect to A equal to AB minus A. That is what is AB? Acceleration of B with respect to ground means that is 5 meters per second square. 5 meters per second square minus acceleration of A is 0. Why? Because he is at rest. Therefore 0. That is 5 meters per second square. 5 meters per second square. Right? Now displacement covered by B with respect to A. That is SBA. Also can be written as SB minus SA. That is SBG minus SAG. What is SB? That is 20 meter. 20 meter. That is 20 meter minus what is SA? 0. Why? Because he is at rest. Therefore 20 minus 0, that is 20 meter. So these are the particulars of B as measured by A. Right. Now number 4, example 4. This time person A also moving along with the B on the same trolley. Right? On the same trolley like that. See, this is the given trolley, right? On which here two persons are standing. Person B here, person A. Now same only particulars with respect to ground. Right? What are the particulars here? What are the particulars? Velocity 10 meters per second. Right? Acceleration 5 meters per second square. Displacement 20 meter. Displacement 20 meter. Right? Now what makes the difference here? These are the particulars in first case with respect to ground. So same only particulars with respect to ground. But here what makes the difference? Person A initially is at rest condition on the ground. But in this case the same person moving along with B on the same trolley. Right? Now A himself observer in this case also. He is going to observe these particulars of B. Right? Now let us see. Let us see. Velocity of B as measured by A. That is VB minus VA. Alright. VB minus VA. That is otherwise VBG minus VAG. Right? Velocity of B with respect to ground. VB means VBG. VA means VAG. VBG. VH. That is, what is VBG? Velocity of B with respect to ground means 10 meters per second. Why? Because with respect to ground, see, this trolley is going at this speed. At the same time, B also moving with the same speed with respect to ground. So therefore, 10 meters per second minus what is the velocity of A with respect to ground means again 10 meters per second. Right? 10 minus 10, that is 0. Now coming to acceleration. Acceleration of B as measured by A. Acceleration of B as measured by A. That is equal to acceleration of B minus acceleration of A. Also can be written as acceleration of B with respect to ground minus acceleration of B with acceleration of A with respect to ground. That is, what is the acceleration of B with respect to ground? That is 5 meters per second. 5 meters per second. Why? Because he is moving along with the trolley with respect to ground. So therefore 5 minus at the same time A also moving at the same acceleration with respect to ground. So 5 minus 5, that is 0. Right? Now coming to displacement covered SB with respect to A. Displacement of B as observed by A. That is SB minus SA. That is SBG minus SAG. What is SBG? That is 20 meter. This is what displacement covered by B with respect to ground. That is 20 minus same only the displacement even for A also, that is 20. That is what? 0. So all the three factors are 0. All the three factors, velocity, relative velocity of B, acceleration of B, and even displacement of B as measured by A. In all the three cases we got 0, 0, 0. But same only in previous case these are the particulars. Relative velocity of B with respect to A 10 meters per second, acceleration of B with respect to A 5 meters per second square, but displacement of B as measured by A 20 meters per second. What makes the difference? In both cases A only observer. In both cases A only observer, right? A is the observer in both cases. Who is going to measure velocity, acceleration and displacement of B only? But here in the first case we got the particulars as 10 meters per second, 5 meters per second square, 20 meters. But here it is velocity, relative velocity 0, relative acceleration 0, relative displacement 0. What makes the difference? Even for the same observer, right? The particulars of same body A are different in both cases. What makes the difference? Think once. What makes the difference? See here. In first condition, observer is at rest. Observer is at rest means he is inertial observer. So a frame attached to himself becomes inertial frame. So these are the particulars measured as per the inertial frame of reference. But here the same A also accelerating along with travel, right, with respect to ground. Now a frame attached to A is not at all inertial frame, that is non-inertial frame. So this time A becomes non-inertial observer. Why? Because he is accelerating apart from travel, right? So therefore here A becomes non-inertial observer. A frame attached to himself, otherwise a frame attached to trolley, accelerating trolley becomes non-inertial frame. So these are the measurements taken as per the non-inertial frame, otherwise as per the non-inertial observer. So in first case A becomes inertial observer and frame becomes inertial frame. In second case A becomes non-inertial observer and frame becomes non-inertial frame. So that makes the difference in getting different values, right, for the same quantities. See here VBA 10 meters per second, here same VBA 0. Here ABA 5 meters per second square, but here ABA becomes 0. Here SBA 20 meter, but here SBA becomes 0, right? So what is the reference here? Displacement, acceleration, velocity, all the three factors changing as per the frame of reference chosen, as per the frame of reference selected, right? So in inertial frame these are the particulars, in non-inertial frame these are the particulars, even for the same body with respect to same observer. So what makes the difference? A type of frame of reference makes the difference. Here these are the particulars as far as inertial frame of reference is concerned. These are the particulars as far as non-inertial frame of reference is concerned. So as displacement, acceleration, velocity dependent on frame of reference, these quantities are known as relative quantities, not absolute quantities, relative. So therefore what is the note point here? What is the note point? What is the note point? Displacement, velocity and acceleration. These are dependent on frame of reference selected. So these are frame dependent, frame dependent in the sense relative quantities, frame dependent or relative quantities, relative quantities. Quantities, right? But time is absolute, it is unique in all frames. Therefore, so this first point, but we have one more point, that is time. So if you calculate time in any frame of reference, that is unique. So time is absolute, time is independent of otherwise frame independent of frame. So it is absolute. So time is absolute as it is independent of frame of reference, but displacement, velocity, acceleration dependent on frame of reference. So these are relative quantities, but the time is absolute quantity. Okay. Now example 4. In this example, person A again at rest condition on the ground, but person B moves at a speed of 2 meters per second with respect to trolley. At the same time, trolley moves forward at 20 meters per second with respect to ground. Now, what is relative velocity of B with respect to trolley? Relative velocity of B, Vb, with respect to trolley equal to Vb minus Vt. That is Vbg minus Vtg here. Am I right? Vb means Vbg. Vb means with respect to ground. Vt means with respect to ground. Right? T means T stands for trolley. B stands for person B. Right? A stands for person A. Now Vbt means velocity of B with respect to trolley. That is absolute velocity of B minus absolute velocity of trolley. Now what is Vbt with respect to trolley? What is the velocity of B? 2 meters per second. Rightwards. That is in the same direction as that of trolley. See? Same direction. So positive. 2 equal to Vbg unknown. Absolute velocity of person B with respect to ground, that is unknown, minus Vtg. What is Vtg? Velocity of travel with respect to ground, that is 20 meters per second. 20 meters per second. That is Vbg equal to 20 plus 2, 22 meters per second. So this is what velocity of B with respect to ground. That is absolute velocity of person B with respect to ground is 22 meters per second. Now, A measures as the B moves with what speed? That is velocity of B with respect to A equal to Vb minus Va. That is Vbg minus Vag. That is, what is Vbg? 22 meters per second. 22 minus Vag. What is acceleration of, velocity of A with respect to ground? 0. That is 22 meters per second. So, in this situation, A measures as B moves at a speed of 22 meters per second forward, that is rightwards, correct? If I reverse arrow mark of 2 meters per second here, suppose if I make it reverse velocity of B like that, means this time B moves at a speed of 2 meters per second with respect to trolley in a direction opposite to that of direction of motion of trolley. See, trolley moves rightwards, but with respect to trolley, person B walks on the same trolley 2 meters per second leftwards, like leftwards, right? Now Vbt, what is Vbt? Vbt equal to Vb minus Vt, that is Vbg minus Vtg. In this case, what is Vbt? Is it plus 2 or minus 2? See, as far as trolley is concerned, what is the direction of motion of trolley? Rightwards. So with respect to this direction, person B is moving opposite direction. So with respect to this direction, here Vb is minus 2. So minus 2. Here it is minus 2. That is minus 2 equal to Vbg minus Vtg. Vtg means 20. That is rightwards. So minus of plus, that is 20. Therefore, Vbg equal to 20 minus 2. 18 only this time. 18 meters per second. Now, velocity of B, person B with respect to person A equal to Vb minus Va. That is Vbg minus Vh. What is Vbg? 18 meters per second. 18 meters per second. Right? Minus Vag. Velocity of A with respect to ground, 0. Why? Because he is at rest position. So, 18 meters per second. Right? Now, number 5. Suppose A also in motion like that. What is the velocity of A with respect to ground, that is 8 meter per second. 8 meter per second, right? So for this particulars, this is okay. VBG is 18 meter per second, right? But VBA equal to VB minus VA, VBG minus VAG. That is, what is VBG 18 minus what is VAG? VAG equal to 8 meter per second. 18 minus 8, that is 10 meter per second. 10 meter per second, right? See here, person A is not at all rest condition in this case, that is number 6, number 6 or number 5, number 6, right? So in this case, person A moves at a speed of 8 meter per second rightwards, that is in the direction of motion of trolley with respect to ground. But on the trolley, person B is moving at 2 meter per second leftwards. Now A finds as if B moves at a speed of 10 meter per second, right? At a speed of 10 meter per second, okay, right? Suppose here person A is on another trolley like that. Person A is on another trolley like that. Number 7, person A is on another trolley like that. Person A, that is moving at 8 meter per second with respect to trolley. With respect to trolley, right? What is the speed of A with respect to trolley? That is 8 meter per second. 8 meter per second. What is the velocity of B with respect to trolley? 2 meter per second. Here it is leftwards, but here it is rightwards. Alright? So as far as VBT is concerned, same only, VB minus VT, VBG minus VTG. VBT means minus 2. So up to here same only. As far as VBG is concerned, 18 meter per second. But VBA, how to find VBA? Before that here, what is the velocity of trolley here? As an example, 10 meter per second with respect to ground. With respect to ground, right? See, in first case here, in trolley, this is what trolley 2, this is what trolley 1. So VB T2, that is T2, right? Okay. So VB T2. Okay. Now, as far as trolley 1 is concerned, what is the speed of trolley 1? That is 10 meter per second with respect to ground, rightwards, right? So what is the velocity of A with respect to trolley 1? That is 8 meter per second. So likewise here also, VBT1, that is velocity of VAT1 equal velocity of A with respect to trolley 1 is equal to VA minus VT1, right? That is VAG minus VT1G. That is VA with respect to ground, otherwise VT1 with respect to ground, right? That is VAT1. What is VAT1? Velocity of A with respect to trolley, 8 meter per second. See, with respect to trolley, written somewhere here, right? With respect to trolley, 8 meter per second. That is in the same direction as that of a direction of motion of trolley. So therefore 8 is positive. So plus 8. 8 equal to VAG minus VTG. What is VTG? So VAT1. So VAT1 is 8. That is VAG unknown minus VT1G. What is the velocity of trolley 1 with respect to ground? That is 10 meter per second. 10 meter per second. That is VAG 10 plus 8. 10 plus 8, that is 18. 18 meter per second. See here, absolute velocity of B, 18 meter per second. Absolute velocity of A also 18 meter per second. Am I right? Now, what is the relative velocity of B with respect to A? That is VBA. VBA means velocity of B as measured by A is equal to velocity of B minus velocity of A. That is absolute velocity of B with respect to ground minus absolute velocity of A with respect to ground. That is what VBG means 18 minus VAG also 18. VAG also 18. 18 minus 18, that is 0. So absolute velocity, relative velocity of B with respect to A is 0. Means A finds as if B is at rest. A finds as if B is at rest as far as B is concerned. Am I right? Okay. Right? Now, let us see one more numerical here. See here, this is what equilateral angle of side A. So this side A, here also side A. Right? Here, three persons are there: person A, person B, person C, at three vertices. Right? All the three persons are moving at a constant speed V, such that A always heading towards B, B always heading towards C, C also heading towards A, which was already done in previous lecture. But there we used the conventional method. This time we are going to use relative velocity method. Okay. Right? See, person A, person B, person C are going to move in such a manner that A heading towards B, B heading towards C, C heading towards A. What are the speeds of all the three persons? V1. Right? Well, speed of A V, speed of B also V, speed of C also V. Right? See here, person B heading towards C. So what is the path followed by B like that? Right? At the same time, person C heading towards A. So what is the path followed by C like that? Right? Like that. Now, person A also heading towards B. So what is the direction of motion of A? This is the direction of motion of A. Say, the direction of motion of C adjusting himself, the direction of motion of C adjusting itself as per the direction of motion of A. So this is the path followed by the C. At the same time, as far as C is concerned, B also changing its direction as far as direction of motion of C. So this is the initial direction, but as far as direction of motion of C is concerned, it is deviating its direction from straight line like that. So always adjusting its direction with respect to direction of motion of C. At the same time, A also adjusting its direction with respect to B. So initial direction is, this is the initial direction, but with respect to B, A also changing its direction with respect to B. So all A, B and C meeting at the centroid. So this is the direction of motion. This is the direction of motion for B and C. This is the direction of motion for A and B like that. A and B. Right? So all A, B, C meeting together at centroid. Right? Now the approach is relative velocity concept. Same only written here. A, B, C. What is the angle? 60 degrees. What is the velocity of B initially towards C? Right? What is the velocity of C initially towards A? But what is the component of velocity of C towards A? If it is V, this is what V cos theta. V cos theta. So velocity of B is V towards C. Velocity of C towards B is V cos 60. V cos 60. See, this is what V. This is V cos 60. Now, what is the relative velocity of B with respect to C? V relative equal to V minus V cos theta. Am I right? See, these two opposite to each other. These two opposite to each other. So, what is the velocity of B with respect to C initially means V minus V cos 60. That is V plus V cos 60. That is V plus V into cos 60 1 by 2. That is 1 plus 1 by 2, 3 by 2 V. 3 by 2 V. Right? What is the time taken in meeting together at the centroid means here distance equal to speed into time. So distance equal to speed into time. That is S relative equal to V relative into T. T is not relative, that is absolute. So T equal to S relative by S relative by V relative. What is S relative between B and C? What is the relative separation between B and C initially? That is A. That is A. A by V relative means 3 by 2. 3 by 2. That is 2A by 3V. 2A by 3V. Okay. This is what simple explanation as far as relative concept is concerned. Okay. Right. Finally, one more numerical. With this I conclude. So let us see. Here, one train is there of length 150 meter. What is the speed of constant speed of train? That is 20 meters per second. VT means speed of train. That is rightwards. Right. What is the length of the train? 150 meter. Now here, a bird flies from front end of the train up to tail end. Right. From the front end to the tail end. Again from tail end to front end. See, at a speed of 30 meters per second. See here one bird is there, right, which is going to fly in such a way that from front end to tail end. Again from tail end to front end at a speed of 30 meters per second. Now this is what one round trip. So going like that and again like that. So one round trip, right? Now what is the find the time total time taken by the bird in a round trip. So to fly like that. One initially opposite to direction motion of the train, again in the direction motion of the train. Right? So this is what one round trip. Right? What is the constant speed of train here? 20 meters per second. What is the constant speed of bird here? 30 meters per second. Right? So in this example, see, this is the path followed by the bird. Path followed by the bird. Right? So this is the path opposite to direction motion of the train initially. What is the time taken? That is T1. Right? Again from tail end to front end. Right? What is the time taken here? T2. Right? T1 plus T2 is unknown. T1 plus T2 is unknown. Now here what is the relative velocity? That is, say, this is what initial direction motion 30 meters per second leftwards, but the train is rightwards. Now what is the relative velocity? V relative equal to relative velocity of bird with respect to train is 30 minus of minus 20. 30 minus of minus 20. Why? Because these two, see, arrow mark here. These two arrow marks opposite to each other. 30 leftwards, 20 rightwards. So velocity of bird with respect to train initially, that is VB minus V train. VB minus V train. VB with respect to train, that is VB minus V train. That is VB means 30. Here 30 minus of minus 20. That is 50 meters per second. What is the time taken here? T1 equal to distance by speed, relative speed. Distance S relative by V relative. S relative means what? 150 meter. See, relative distance to be covered, that is 150. Means length of the track. That is 150 divided by relative velocity. What is relative velocity in first case? In the first case, while moving opposite to the direction of motion of train, that is 50 meters per second. That is 150 by 50, that is 3 seconds. Right? Now see, while flying from tail end to front end, see this arrow mark. Time taken is T2, but relative velocity VBT is VB minus VT. That is, what is VB? 30. Rightwards. Train also rightwards. So both are positive. That is 30 minus of plus 20. 30 minus of 20. Minus of plus 20. That is 30 minus 20 means 10. So 10 meters per second. Right. Now T2 equal to S relative by V relative. That is L by VBT. L by VBT. S relative means again the bird has to travel a distance of 150 meter only. See, this is 150 meter, this one also 150. So what is the S relative here in second case while flying from tail end to front end? That is 150 again. So 150 divided by relative velocity in this case 10 meters per second. That is 10. So that is 15 seconds. So T1 equal to 3 seconds, T2 equal to 15 seconds. So total time T equal to T1 plus T2, that is 3 seconds plus 15 seconds, that is 18 seconds. So this is the time taken by the bird for entire round trip. Okay, friends.